Hi, in this video we are going to look at different methods for hydrograph routing. In the previous video we learned that when the water moves from point X to point Y, this is how the shape changes. Okay, so we have the hydrograph at Qx and then we have hydrograph at Qy. Okay, so as the hydrograph moves from upstream location X to downstream location Y, we have attenuation and we have flattening. So there are two methods that are used for routing of hydrographs. So the first method is called hydrologic routing. And this is the simplest method compared to the other method, which is hydraulic routing, which we will discuss after this. So in hydrologic routing, we use two different set of equations. So the first set of equation is continuity equation, and this in hydrology is basically ds over dt is equal to I minus q. So change in storage is equal to inflow minus outflow. So this is one equation, and the another equation is some sort of relationship between storage and outflow and also sometimes inflow. Okay, so S is function of I and Q. So these two set of equations are used when we route the flow using hydrologic routing method. So in this case basically we study change in shape of hydrograph with respect to time only. Okay, so you may ask, since the hydrograph is moving from point X to point Y and X and Y are locations, so how are we just doing it with respect to time? Well, in this case we can think of that at point X the hydrograph may be present at time t, and when it goes from X to Y the time changes from t plus delta t. So that's the simplest way to think about it. Okay, so in hydrologic routing we use two set of equations, continuity equation and some sort of relationship between storage and outflow and sometimes also inflow. This is hydrologic routing, and as I said this is a simpler compared to the other methods, so relatively less complex and is mostly used in reservoir routing and channel routing when the flow is gradually changing, or you can say gradually varying flow and no significant backwater effects. Okay, and the second method is hydraulic routing. So hydraulic routing is also called as distributed and similarly hydrologic routing is also called as lumped routing. And you may have heard lump hydrologic model and distributed hydrologic model. So let's think about hydraulic routing now. Hydraulic routing is relatively more complex. So again, we use two set of equations. So continuity equation or conservation of mass equation, which is ds over dt is equal to it minus qt. And the second equation is momentum equation. So this could be Saint Venant equation or dynamic wave equation. And you may have heard or used these differential equations, which we are not going to use in this class. So hydraulic routing involves continuity and momentum equation, and here we study the change in hydrograph shape with respect to both space and time. Okay, so as I said, hydraulic routing is more complex, and that complexity comes from this momentum equation, and this is used when we have complex flow conditions in river channels, and this could be rapidly varying flow, dam break, or something like that. So example, dam break. Okay, so there are two methods. One is hydrologic or lumped routing, and the second method is hydraulic and distributed routing. As I said, in this class we will only be focusing on hydrologic routing. So again, there are many methods. In this class we will only focus on three methods: hydrologic routing methods. So the first method is linear reservoir, and I will explain in the next module what linear reservoir method is. So this is the simplest method. The second method is Muskingum channel routing. Okay, we can think of this as semi-distributed, used for river channels. Okay, and the third method is reservoir routing, or level pool method, or modified Puls method. And this, again, as the name says, mostly used for reservoirs, and sometimes it can also be used for simple channels. So these are the three methods that we are going to study with regards to hydrologic routing method. and we will not be studying hydraulic routing in this class. So this is all for this video, and in the next video we will learn what do we mean by linear versus non-linear reservoir, and then we'll start about how to go on using these methods. So this is it for this video. I will see you next time. Thank you.